All right, everyone. Everything in our training has been leading to this moment. We've been practicing with rational expressions, adding, subtracting, multiplying, dividing, simplifying, all for this moment. We are going to begin to look at equations that have rational expressions in them. And so when we're solving these equations that have rational expressions on each side of the equal sign, what we're going to do is we're going to multiply with cross products. Now, this should look familiar. This is something you've done in the past, but maybe just not to this extent. So we are just going to be doing cross multiply and then solve. But then it is important, make sure you take note of this, that we always need to check for extraneous solutions, and our denominator cannot equal 0. So jumping right in, I am going to multiply cross products. So I'm going to look at this diagonal, and I'm going to look at this diagonal. And it doesn't matter which one goes on which side of the equals. It can be whatever. So I'm going to write it out first like this. 2 times x squared minus 2. And then I'm going to have equals. And then this one I'm multiplying negative 2 times x minus 4. Well, multiplying all of that out, I'm going to use the distributive property, and I'll get 2x squared minus 4 equals negative 2x plus 8. So when I go to solve this now, I have to think a little bit logically, I guess, about what should my next step be. What I'm going to do is notice that I have an x squared and an x and a constant, which tells me that I'm going to have to use something quadratic related. I'm going to have to factor or quadratic formula, something. So I'm going to start by getting everything on the same side. So I'm going to bring this 2x over, and I'm going to bring the 8 over, because I like having a positive x squared. I think it just makes life a little bit better. So I'm going to come up here and do this over here. We've got 2x squared plus 2x minus 12 equals 0. Now, first thing that I always check for is that GCF. So I've got a GCF of 2. And now, if I check if I can factor this, I'm saying what can multiply to 6 and subtract to 1? 3 and 2. So I'm going to have x and 3, x and 2. This tells me that the signs are going to be different, and this one goes with the bigger number. So to solve this, I set each of my factors equal to 0. Remember that a constant GCF without an x is irrelevant when solving. It's important for the equation, but I would get that x equals negative 3 and x equals 2. When I set x plus 3 equal to 0, I solve that and get x equals negative 3. So these are my answers, but let me just do a little quick check for extraneous solutions. So if I were to plug in negative 3, really the only thing that would make this, well, it would make it extraneous if they weren't the same thing, but I especially want to check those denominators. And this is where we did do a lot of practice finding those points of discontinuity. So here in the denominator, I would have negative 3 squared is 9, minus 2 is 7. So for that first one, I would have negative 2 over 7. Then I would have 2 over negative 3 minus 4, which would be negative 7. So I've got 2 over negative 7. Now, remember that with fractions, it doesn't matter if the negative's in the numerator or denominator. As long as there's only one, it's the same thing. So that answer works. Let's plug in 2. We'd get negative 2 over 2 squared is 4, and 4 minus 2 is 2. And then for the second one, I'd have 2 over 2 minus 4, which is 2 over negative 2. So that answer also works. So that means that both of these were in fact solutions. All right. So to start this one, go ahead and cross multiply these. and see what you get. I want you to stop after it looks like this right here. Go ahead and like multiply everything out. All right, we should get, when I multiply -4 times x plus 2, I should have that there. And then for this one, I have two different ways to do this. I could distribute the 5 to everything and then distribute 3, or I could multiply 3 and 5 together. And that's what I'm going to do and get 15. So I only have to do distribution once. So I'm going to get -4x minus 8. And then I'm going to get equals 15x plus 30. Go ahead and finish that problem and see what you get. All right, so this is what I got. I got x equals 2, but I want to do a check and see if it works. So when I plug in 2, I would get -4 over 5 times 2 plus 2 is 4, so 4 times 5 is 20. Over here, I'm going to get 3 over 4. 2 plus 2 is 4. So, sorry, my fault. This should actually be a -2. So that would make this be, over here, we'd have a -20 in the denominator, but here I'd have -2 plus 2. And so actually that's going to make this denominator be 0. And since I have a 0 in the denominator, that means that this is an extraneous solution. And that means that this one actually has no solution because there is no other value of x that we could plug in. So overall, there's no value of x that we can plug in to make this be a true statement. All right. Whoop. All right, go ahead and set this one up. Start it on your own, and then we'll check in and see how you did. All right, so this is where you should be at this point. When we see the x squared minus 49, I know I've been harping on you guys to simplify, and so you're looking for, oh, I can factor that. Don't factor that into x plus 7 and x minus 7, because even though it's going to end up matching something over there, we can't really do anything with it. We can't cross anything out, so you're just going to end up right back at this point. So I got x squared plus 7x over here, move both of those to this side so that I have that positive x squared, and I end up with x squared minus 7x minus 98. So I need two numbers for that multiply to 98 and subtract to 7. What could they be? That would be 14 and 7. So I'm going to factor this into x 14, x and 7. And then I'm going to say this sign means that they're going to be different. And this tells me that the negative, or this sign right here, goes with the bigger number. So -14 plus 7. When I solve this, I get x equals 14, x equals -7. All right, so let's do a quick check here. Right off the bat, I can see that if I plug in -7, that's going to give me a 0 here and here, actually. So that one is a super extraneous solution. So I'm going to cross that out. But if I plug in 14, I get 2 over 21 equals 14 over 14 squared would be 296. Oh, sorry, 196. I was doubting my math, and I was right to doubt it. And then minus 49 would give me 147. Now, if I were to simplify that, right now it looks like, we have another extraneous solution, but I can actually simplify this. I can divide both of those by 7, and that would actually give me a 2 and a 21. So I do get the same thing. So that means x equals 14 is the only solution. So between these three examples, you can see we had one where both of our solutions worked. We had one where none of the solutions worked, and we had one where one worked and one didn't. So that checking for the extraneous solutions is going to be super duper important. So please don't forget that step. All right, got a couple more. So I would like for you to try this one on your own completely from beginning to end and see what answer you get. Don't forget to check for extraneous solutions. All right, If you need to pause for a second and check your work, you can. But you can see we got an answer of x equals -1. When I plugged it in, I got 1 over -1 equals 5 over -5. And we hopefully know that those do end up reducing to be the same thing. So that tells me that I get an answer of x equals -1. This is a true statement. All right, last one. This is another one that I'm going to have you just try on your own to see how we're doing, and then we'll check back in and see how you did. Okay, so when we solve this, we are factoring. Don't forget, if you decide to factor with this method of multiplying the 3 to the end, you do have to come back here and divide by 3 at the end. So I got x equals 4/3 and x equals -1. And so when I plugged in 4/3, I know that's not everybody's favorite because it's a fraction, but 4/3 plus 1 would give me 7/3. And then when I do 3 divided by 7/3, I get 9 over 7. If you want to talk more about that, we can. And then over here, I did 4/3 squared, which is 16 over 9, minus 1, which gives me 7 over 9. And so then 1 over that would be 9 over 7. So since these came out to be the same thing, that is a true statement. But when I plug in -1, I immediately get a 0 in the denominator. I didn't even finish the problem. I just said that is an extraneous solution. So that is an introduction to solving equations. We are going to continue to work with these over the next couple of days. So if you have any questions that you would like to have answered now, please make sure to let me know, and we'll do what we can to get that process of figuring all this out started.